So I'm Troy Jones. I am the RISC-V CPU product manager for Tenstorrent. Very happy to be able to present this information to you guys. So what is the history of Tenstorrent? From a RISC-V perspective, this is not new to us. We have used all different flavors and heritages of RISC-V through all of our AI inference and training boards, our SoCs, and we are moving forward into producing that IP for general consumption as well, i.e. that is the IP I'm going to talk to you here in just a second. So we have recognized as many, I'm not naive to the fact there are other high-performance RISC-V vendors out there, but we are very much at the premier level and validated and tested IP, and it's all about the high-performance side of things. There are many, many embedded guys out there, not so many high-performance one. And so that's why I want to show to you guys Ascalon, okay? So now, again, we have been talking about Ascalon as a whole in the industry to Tier 1 customers for a while. But again, my point here today is to show to you guys that this is available and accessible now, okay? The first week in November, so that's what, 2 weeks from now, it is actually going into our EA status. We defined early access, so that is production candidate quality RTL that you guys can get your hands on. So you can see some of our scores here. We're over 21 spec int 2K6 per gigahertz. Okay, we also run the 2K17 scores, both at int and floating point. Very proud of those numbers. We have currently run through all physical design and back-end tooling for SF4X, so Samsung node at 2.5 gigahertz. Okay, and this is all validated and verified. Okay, some of the other architectural features of an RVA23 machine, as you would expect, we have dual 256-bit vector paths, RVV 1.0 compliant, advanced branch prediction, prefetchers, so the things you want out of a good CPU. The software environment, GCC, LLVM, is all upstream and available. You can go grab it right now, and it is available. Okay, what are our target markets for this guy? Again, being a RVA23 machine, we're targeting robotics. That would be inclusive of the automotive side of things. Infrastructure, of course. Servers, high-performance compute, data centers, networking. And then also those entities that are looking for sovereign compute, in terms of more HPC, mission-critical systems. So again, I would assume since we're all here at the RISC-V Summit, everybody kind of understands the space that an RVA23 machine would play in. Of course, that's where we're heading with that. This is a slide for any of you that sat through the 2-minute speed dating session yesterday afternoon. I kind of give you guys a teaser on this slide. This Ascalon microarchitecture is a very scalable architecture. Now, the one that we are coming out with out of the chutes is the far right, the Ascalon X. So that is an 8YD code, our big boy, right? Typical for IP development. You come out with the biggest, baddest first. But it is a scaled architecture so that you can go down into a couple of different, as I call them, buckets. From low power, low area, to kind of midline, et cetera. So U, S, H, and X are the names that we are using. Performance, okay? Our goal for Ascalon was really 2 major items. Quality RTL, okay? This stuff works. I have to give credit to Div Yang and our engineering team. They've gone through extreme levels to make sure that this is proper RTL, okay? In that, we have our performance numbers that pop out of it, okay? So you can see there on the far right, there's our Ascalon X. Again, that is at the 21 spec int 2K6, very much equivalent to a Neoverse V3 quality of a core. Just as an example, the scalable nature, the Ascalon S, that would be a 4Y decode machine, is going to be about 14 spec. So again, it's very scalable in nature, on purpose. We cluster these guys. Again, as you kind of expect for a high-end CPU, they're going to be clusters. We can go 2, 4, or 8 CPUs in a cluster. These CPUs share a coherent L2 cache, and it interfaces to the outside world via Chai, version E at the time, and AXI5 for non-coherent traffic. Okay? We also have an AXI4 port, more from a management style port, that's available as well. Internal to this clustering, obviously you get the CPU and all of its good stuff, private L1, private MMU, okay, debug, floating point unit, memory management. The cluster also then includes the interrupt architecture, trace and debug, okay, power management, again, what you would expect out of a nice CPU. Okay. This is something I'm extremely proud to talk about here. As I said, this Ascalon IP is very real. We are in the process of designing and taping out and working through the first RVA23 chip that's going to be available on the market. Call it Atlantis. Okay? So this will be an 8-core cluster Ascalon X CPU. Okay? Again, we see all the target markets. It's really going to be great for starting to do software development. Okay? It's an SoC with that architecture put onto a development board. Okay? So here's kind of a list of the components that are going to be on this board for you guys to utilize. This will be coming out late Q2, Q3 of next year. So it's a very real and available piece of hardware very soon. We're working very tightly with some partners in the industry. I think everybody knows Canonical and Ubuntu, right? We have decided and are working with them. So your out-of-box experience will be booting at least Ubuntu 25.1, if not hopefully 26. I mentioned robotics as one of our target industries. With that, we are taking Ascalon, adding all the necessary functional safety componentry to it, including STLs, software test libraries, and it will be called Alexandria. Alexandria is Ascalon for automotive industry and robotics. It will not only be ASIL B and ASIL D certifiable, it'll be ASIL B and ASIL D certified. So you guys will be able to take that certificate and use it moving forward to do the entire SoC and board level certification process. This guy is going to be coming out third quarter, early fourth quarter next year as well. Okay. Actively under development on top of the Ascalon that's available next week. I apologize for some eye charts here. It's not too bad. It's more than producing RTL for a CPU. You got to have all the building pieces, the ecosystem. So what are we doing at Tenstorrent to facilitate this? Okay, the system IP, all the blocks around it. I mentioned earlier on the IOMMU, the interrupt controller stuff. That's only part of it. The rest of this laundry list are components that we will be providing for you to build out the SoC that includes Ascalon. Likewise, not just from the hardware side of the system IP, but the infrastructure, the tooling, the collateral, all the documents, okay? Again, if you want a high-end CPU, you're going to expect all those components to be available to you. So reference models, the silicon tools, we give you DV guidance, we give you, physical design guidance out there. Emulation platforms. As I mentioned, overrunning in the booth right now, we have the HAPS 100 from Synopsys running our Ascalon X, and it's running Doom. Hey, anybody heard of the game Doom? Yeah, when my engineering team told me that they were targeting Doom, I was like, okay, that's cool, 20 years ago. No, but I think the idea is it shows the complexity and the capability of an RVA23 CPU and what it can do, okay? Quick emulator, the model's already up there in QEMU right now, so you can go download that and play with it today. And then as I mentioned on the bottom right there, we have platforms, the Atlantis board and stuff coming out early next year. Quake, that's next. All right, now we couldn't have gotten where we're at today without a lot of participation from the ecosystem as it is today. So I'm sure you guys recognize many of these different icons and names that are here. Tenstorrent as a whole is all about enabling the RISC-V ecosystem, the reason we're all here. So anything that we do software related is always going to be open. Now, open has kind of gotten a bad rap over the last few years. What does open really mean? I'm not going to go into that debate with you guys right now. It's a whole nother 4-hour conversation. But the idea is any optimizations that we do for RVA23 are going to be in GCC, in LLVM. Okay? We're not holding that tight in our back pocket. It's for all of us to be successful with this type of CPU. Okay? We have board members on RISE. We're very tightly integrated with RISC-V International as a whole. Okay? We're not shy about this. We are driving the industry forward. Kind of a generic slide. What is it not? It's not just an RTL CPU. It's everything you guys need to be successful. Okay? All the system IP, all the documentation, the platforms, emulation or hardware otherwise. Okay? And again, the big deal for us is that you guys are going to own your silicon future, right? Kind of a buzzword that we like to use is you are not tied to any of the other vendors that we're all trying to displace here. That is our plan as well as Tenstorrent. Okay. Quick sneak peek at our roadmap. What's beyond Ascalon? Okay, so you see there on the left side of the screen, Ascalon and the system IP. Well, coming up over the next 2 years and beyond, so Babylon and Searing, the top row, are the next generation. It's the same microarchitecture, so we call it the Ascalon microarchitecture, but it will be better area, better performance, all the components as you start advancing RTL forward. Searing, same thing, it's just the next advancement of that. System IP will be doing the same thing, just moving forward. We'll be creating automotive variants, ASIL B, ASIL D, of our system IP as necessary for you guys, okay? Down in the bottom middle, you see the Atlantis board I mentioned. And then on the bottom right there, chiplets, okay? One of the big goals and driving forces behind Tenstorrent as well is the chiplet industry, okay? As we all know, chiplets are a very big goal, especially in automotive. And so we will be taking Ascalon and creating a CPU chiplet out of it. We're going to create memory chiplets. We've got our AI IP as well. We'll have AI chiplets. Okay? So again, chiplets are a very big deal for Tenstorrent. Ascalon is going to be one of those. As I mentioned earlier on, one of the goals about Tenstorrent as whole and our CEO is all about being open. So top down, if you look at kind of that chart there on the right side there, all of our AI software is open source, okay? We build systems for that. We have boards and cards that are built out of multi-chip chiplet modules. We'll do the SoC chiplets, as I mentioned, and then that uses our IP. So probably the better way to look at it is bottom up. We start from ground zero. We build our IP. We've been overusing this phrase, but we eat our own dog food. We use what we build. We're not just going to sell you a piece of RTL and say, oh yeah, it's verified, it's been physically designed. We actually use it. Our company will not be successful without using our own IP. So you have confidence that we are going to build it right, because that's our livelihood. Okay. We are, again, I can't stress our engagement in the open ecosystem. We have to rely on everybody in this room to be successful as RISC-V as a whole, okay? So everywhere from the developer community, platforms, all of that, we are deeply engaged. How does Tenstorrent do our business? We are very flexible, okay? We can license the RTL to you. If you want to go through and modify Ascalon, add in custom instructions, that's a possibility. If you want to white label our RTL in your design, that's a possibility. If you want a turnkey design, just buy it as is, of course we have that as well, okay? Very, very flexible in that nature. And of course, it's RISC-V, so no crazy licensing fees around that. So, how do you guys get your hands on it today? As I mentioned earlier, we have Synopsys platforms, ZeBu, and HAPS as well. Okay, so ZeBu is currently cloud-based access. We are also working on getting our HAPS platform cloud accessible. So you guys can literally log in to a HAPS machine. Right now it's HAPS 100. We're in the process of developing HAPS 200, which will be twice the frequency and about 8 times the capacity for the number of CPUs. That'll also be cloud-based. And then Verilator. Okay, Verilator, I think a lot of you probably know what it is, open source version of creating a model of an RTL implementation. Follow that QR code, guys, and you can go register and you can download our Verilator model and start kicking the tires right now. Run Hello World. Now, am I gonna say is it best for doing a full-on spec benchmark? Probably not. It's Verilator, it runs on your host CPU, but the idea is to convince you guys, and so you can physically get your hands on it, this IP is real. You can do everything you want in that Verilator model, I can't say that fast, to play with it. Bottom line, we're open. We're using open architecture hardware. Our software is open, especially from the AI side of things, upstreaming everything. So please stop by. We're over at booth P1, go in the doors, turn left, we're right there. We've got the experts running the HAPS demo. We've got demo hardware for the AI side of the house and the hardware platforms we have. And then of course, please come talk to me if you want any more specific details around the Ascalon CPU. Okay. Again, very proud to say that it is tangible, it's real, it's now. Any other questions? Wait for the mic. Get a mic. Okay. We have a mic running around for people that have any particular questions that I can answer.
Hi, yeah, it's amazing that y'all have an RVA23 compliant processor available today to evaluate, but I'm wondering, is it like a socketed processor or something that would be like directly soldered onto like an SBC? Should you ever offer like individual offerings of that? I'm just curious.
So initially it's soft IP. So a SoC integrator would purchase the IP and build it into their SoC, build the rest of the system around it for their implementation. Mm-hmm. Now I mentioned chiplets. We will be using our chiplet version of Ascalon and putting it into a chip as well. So we will have an actual physical chip with Ascalon available as well. So,
all right.
So that's out there just a little bit, but that is part of the chiplet implementation of Ascalon.
Okay, but right now Ascalon is, even though it's very much a real product, it's right as of right now, it's limited to whatever cloud data centers that you have for validation, correct?
Correct, yeah, it is not physically in silicon as we stand here today. But it will be by the end of Q2.
So it's a very well validated FPGA implementation or something like that?
So yeah, on HAPS, again, right now it's a single Ascalon X core with a 3 megabyte L2 on it or whatever, but that's what we've used for validation and verification, as well as multiple additional configurations. So yeah, if you want to reference our emulation platforms, that's what it would be. It's not physical hardware until about 6 months, 9 months from now.
Okay, thank you.
Yes. Additional questions? All right, well, look at that. I didn't even keep you guys from lunch. So, all right, guys, I'm around for the rest of the show, so please stop by and ask any questions you might have. Thank you.